All right. Today's topic is an introduction to organic chemistry. Organic chemistry is the study of compounds that contain an element carbon. First, let's review some characteristics of organic compounds. The first one, all organic compounds contain carbon atoms, and most of them contain hydrogen atoms. Carbon form 4 covalent bonds, and hydrogen form 1 covalent bond. Okay, the example is methane here. You can see methane is one carbon molecule. Okay, one carbon. Okay, has 4 hydrogen, and you can see carbon form 4 covalent bonds with 4 hydrogen, and hydrogen form 1 covalent bond with carbon. Okay, the structure formula. On this side, you can see the Lewis structure. Lewis structure, you can see electron pairs and between carbon and hydrogen. There's 1 covalent bond. Some simple carbon-containing molecules are considered as inorganic compounds, not organic compounds. Those molecules including carbon dioxide, cyanides, carbon tetrachloride, and sodium carbonate. Okay, those are molecules, although they have the carbon inside, but they are not considered organic compounds. Okay, next, the carbon is able to form a single, double, or triple bond to another carbon atom. Okay, here we have the examples. The first one is ethylene. Ethylene is a 2 carbon alkane. Okay, 2 carbon alkane. Okay, you can see a single bond between 2 carbons, 2 carbon atoms. Okay, each carbon form 3 covalent bonds with 3 hydrogen and 1 covalent bond with another carbon. Okay, the total bonds is 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, the Lewis structure. For the double bond, the example is called here is ethylene. Ethylene is the simplest alkane. It has 2 carbons and a double bond between 2 carbon atoms. Okay, each carbon also form 2 covalent bonds with 2 hydrogen. Okay, the total covalent bonds is 4 for each carbon. All right, so it's a Lewis structure. For the triple bond, the example here is ethylene. Okay, ethylene has 2 carbons and a triple bond between 2 carbons. Each carbon has 1 covalent bond with hydrogen. Okay, the total covalent bonds of each carbon is 4. 3 plus 1. All right. This is that carbon can form a single, double, and triple bond with another carbon. Okay. Next, some organic compounds can be a chain. Okay, just a straight line is trains, a chain of carbons, and some compounds can form the rings. Okay, the example here is 3 carbon alkanes. They call the propane. Okay, propane has 3 carbons. On this side is the chain. Form the chain, 3 carbon chain. They call the propane, and this one they form a 3 carbon ring. Okay, this propane called cyclopropane. Okay, so organic compounds can form a chain, also they can form a ring. Okay, this next characteristic is we talk about is some compounds, some organic compounds, okay, may contain elements other than carbon and hydrogen. Okay, any atom in organic compound that is not carbon or hydrogen is called heteroatom. Okay, most common heteroatom nitrogen, sulfur, oxygen, and halogens. Halogens include fluorine, chlorine, bromine, and iodine. Okay, also oxygen and nitrogen are able to form a single or multiple bonds to carbon. Okay, here we list 4 examples. Okay, and the first one is methanol. Methanol has the one oxygen atom inside. Okay, and the second one is called methanol. Methanol has a sulfur atom. Okay, and next is called chloromethane. Chloromethane has one chlorine here, and the last one is acetonitrile. Acetonitrile has nitrogen. Also, you can see nitrogen form a triple bond with carbon. Okay. Okay. This the characteristic of organic compounds. Next, let's take a look at the molecular formula or structure of organic molecules. Okay, we use Pentane as an example here. Pentane has 5 carbons and 12 hydrogen atoms. Okay, the first one you can see the molecular formula. Okay, C5 and H12. Okay, subscript of carbon is 5. That means 5 carbons, and subscript this 12. Okay, means it was 12 hydrogen. Okay. Next is the complete structure formula. Okay, you can see those bonds, covalent bonds are used. Okay, a solid line. Okay, between atoms represent covalent bonds. You can see all the carbons form 4 covalent bonds, and hydrogen form 1 covalent bond. Okay, and this structure formula can be condensed into condensed structures. Okay, in condensed structures, okay, we just simply remove all the solid lines, those bonds. Okay, and also number all of the write down shows all the carbons and the hydrogens. Okay, we start from this side, and this is a CH3. Okay, and this is a CH2, 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 CH3. Okay, this is called condensed structure. Okay, in this condensed structure, we can see 3 CH2s. Okay, so we can further condense this structure into this. Okay, we use the parentheses and the subscript 3 for 3 CH2 groups. Okay, and then we can write this way: CH3 parentheses CH2 3. That means we have 3 CH2 and CH3. Okay, this is a more condensed structure. Pentane. Okay, the The next is called skeletal structure. Okay, skeletal structure for Pentane is this. Okay, and for drawing a skeletal structure, we have some rule to follow. Okay, the first one is this. There's a carbon atom at the junction of two lines and at the end of each line, at the end of any line. Here you can take this example. Junctions, we have 3 junction points. Okay, 1, 2, 3. Also we have 2 ends, 1, 2. So the total carbon is 5. Okay, 1, 2, 3, 4, 5. Okay, that's the first rule. The second rule for drawing a skeletal structure is we have to assume the hydrogen atom, the bond to the carbon. Okay, although we don't draw hydrogen and the bonds to hydrogen, we can. So the example is here. Okay, this molecule is called cyclohexane, and you can see 6 carbons. Each carbon has 2 covalent bonds to hydrogens. Okay, but when we draw a skeletal structure, okay, we only draw show the bonds between carbon atoms. Okay, and each junction represent 1 carbon. And for example, this carbon has in this skeletal structure has 2 covalent bonds to another 2 carbons. Okay, so you know that the carbon total covalent bond of each carbon atom is 4. So in this case, 2 covalent bonds to hydrogens are omitted. Okay, so although we don't draw here, but immediately we saw when we draw this skeletal structure, we see that there are 2 hydrogens bound to a carbon atom. Okay, that's the second rule. The last one is if the compound has a heteroatom. Okay, you need to draw the heteroatom like this. Also, you need to draw the hydrogen atom directly bound to the heteroatom. In this case, it's a cyclopentane. Okay, you can see this oxygen here and hydrogen directly bound to oxygen. You have to draw the oxygen and the hydrogen. Okay, this hydrogen cannot be omitted. Okay, this is the third rule for drawing a skeletal structure. Okay, next let's take a look at the carbon hydrocarbon compounds. Okay, we have several types of hydrocarbon compounds. Okay, hydrocarbon compound is a compound that contains only carbon and hydrogen. The first type of hydrocarbon compound is called alkenes. Okay, alkenes are hydrocarbons that only have only single bonds between carbon-carbon atoms. Okay, all the carbon-carbon bonds are single bonds. Okay, the example here is ethane. Okay, 2 carbons and 6 hydrogens, and you can see single bond between 2 carbon atoms. Okay, next is called alkenes. Alkenes are hydrocarbons that has 1 double bond between 2 carbon molecules. The example is ethylene, 2 carbons, okay, and 3 and 4 hydrogens, and you can see double bond between 2 carbon atoms. Next type is called alkynes. Alkynes are hydrocarbons that has a triple bond between carbons. Okay, the example is acetylene. Acetylene has 2 carbons and 2 hydrogen. Okay, the triple bond between two carbons, and each carbon also bound to one hydrogen, and the total bonds, the carbon atom form is 4. 1, 2, 3, 4. Okay. The last type of hydrocarbon is called aromatic compound. Aromatic compound is a compound that contains benzene ring. Okay, this is the benzene ring. Okay, three forms of benzene. Okay, the first one is called a complete structure, and you can see 6 carbons and 3 double bonds. Okay, from the 6 carbon ring. Okay, and each carbon has one covalent bond with hydrogen. Okay, and on this in the middle is called skeleton form. Okay, we can draw this, or meet hydrogen. Okay, and carbon. Okay, each junction is a carbon, and so also each carbon has 3 covalent bonds in the skeleton structure. So that means one covalent bond to hydrogen is omitted. Okay, this one is called a resonance form. It's right this way. Okay, in this case, they indicated the location of double bonds. Okay, can be evenly distributed. Okay, so in this skeleton, in this form, and you can see double bond located here in this way, and also we can draw a similar skeleton benzene like this. All right, it's a double bond. So, and then, so this resonance form represents these 2 forms of skeleton form here. All right,